Hello everyone, welcome back to another topic of fluid mechanics. We have been discussing the pressure measurement in the last couple of videos, and we are continuing the same topic in this video with differential pressure measurement. So which is basically measuring the differential pressure of a pipe flow at 2 points, or measuring the differential pressure between 2 points on a pipe flow using a simple manometer. Now we are considering a pipe flow with a fluid of say density A, and the manometer, the simple manometer, have another fluid filled in this with a different density to the fluid in the pipe. Now when you make the connection of the manometer, it is important that the connections are perpendicular to the pipe, otherwise the pressure measurement will not be correct. So you have two planes A and B where we are going to measure the differential pressure across. The manometer is connected at A and B, and it is perpendicular to the tube. Now as I said, there is a pressure in the pipe at plane A and plane B. So we are going to calculate or find out the differential pressure, or the difference in pressure across those 2 points. Now as you will see, the manometer is now filled with a liquid or a fluid that is has a higher density than the pipe, and say the pipe liquid or fluid has a density of ρ1, and the manometer liquid has a density of ρ2. Now as in the previous cases, we are going to calculate the pressure head, which is measured in length, as a length. So you have the center line of the pipe flow, and the top point of the manometer fluid, and the bottom point of the manometer fluid. So I have marked these distances x and y. Obviously you can see pressure at A is higher than pressure at B. Pressure at A, P1, is higher than the pressure at B, P2, and that's why the manometer liquid is higher at the plane B. Now as usual, as in the previous videos, what we are doing is balancing the pressure, or writing the pressure balance equation for this setup, and that will give you the differential pressure across the 2 planes. So let's say at plane A you have a pressure P1, and at point B, or plane B, you have a pressure P2. So we are going to find out the P1 minus P2, and as I mentioned earlier, P1 in this case is greater than P2, which is why the manometer liquid is at a higher altitude at the plane P2. Now if you balance the pressure at P1 and P2, or planes A and B, you get at plane A you have pressure P1 plus there is a height of the pipe fluid, which is the pressure head is x plus y. So the total pressure is ρg times x plus y, and the density is the pipe liquid's density ρ1, and you can balance it with the pressure at plane B, which obviously is the pressure P2 plus the liquid has the pipe liquid has a height of y, and the manometer liquid has a height of x. So P2 plus ρ1 into g times y, which is the liquid in the pipe, and ρ2 g times x, which is the manometer fluid. So if you balance that, if you can take that P2 over to one side, so you can write or rewrite this equation as P1 minus P2 is equal to ρ1 gy plus ρ2 gx minus ρ1 gx plus minus ρ1 gy. I'm just basically expanding that equation, and you can cancel one term in that, which is the ρ1 gy. You have a plus ρ1 gy and a minus ρ1 gy, which is obviously cancelled now, and you will be left with P1. I'm just going to take it to the top. So if you rearrange or arrange that equation again, you will get P1 minus P2 is equal to ρ2 minus rho 1 times gx. So gx is the common term. I'm just taking that out from the equation. So gx times rho 2 minus rho 1. Now that's a differential pressure. You probably won't get P1 and P2 individually, but you will get the differential pressure across those two planes. Once again, thank you for watching. If you have any doubts or comments, please add them and I will respond accordingly. Thank you very much.